Now, we have in our previous lecture, we talked about what is data visualization, the history of data visualization. Now we came to this point, and some of the concepts related to effective visualizations and cognitive theory. We talked about what is this extraneous load, what is the germane load, and what to avoid. Right. So remember, there was an example like our working memory is something that is like a table. So you need to make sure that you don't have a clutter on the table. You only focus on whatever that you are working on. So the German load was about what the user or the audience, the viewer is going to take from what you present, and how he or she is going to connect what he or she sees in your visual to what the knowledge is about. So that's German load, and you have the extraneous load that is stressing the viewer up because of unnecessary visuals and the clutter. So we also talked about this data to ink ratio to make sure that whatever you want to show and the in terms of the information is available on the visual itself rather than the unnecessary things. Now, as you can see clearly, it is not only a science, it is also an art. So you have to have a blend between art and science to do proper data visualization, not only proper, effective data visualization, because we can look at the same problem in different ways. This is not a very long lecture. It is about also something that we already know. So I'll start with that. Data visualization is a complex process involving art and science, aiming to accurately convey data without misleading or distorting it. Now, if you look at this particular visual on the screen, it is a very nice flower, but it's a micro level view of this flower. And you can see the connectivity of each of them to the center. When you look at this from afar, you will not see this connectivity. You only see the flower as a whole, as an entity. But as you come closer, you will see the connectivity and the derivatives or whatever the things associated with that visual, right? If you remember the pointer list analogy that we talked about in our last lecture, where you imagine a visualization as points, combining points, the agglomeration of points, but in a macro level structure. So you look at it from the ground level up, you see some connectivity, and as from a helicopter view or maybe a view from afar, you see something else like a completely different thing. But the connectivity and the details involved in that visualization has to be coherent, and it has to be clear. So that's how a proper visualization is made. And now if you look at the like different types of visuals, we also talked about this in the data to ink ratio and the when you talk about the extraneous load, right? Where you put things that are unnecessary. The viewer is expecting something else, but you are bombarding with information that the viewer is not willing to take or has to take because it's there. Now, if you can look at the number one here, it has visualization here. So it has some unattractive features. The visualization is not wrong. It is not wrong because you have proper labels for your bars, A, B, C. And also the bar heights are properly given. You can see the height and you can clearly identify what is what. And the y-axis is properly labeled as well, and the numbers are there. So it's proper, it's accurate. But the problem is it is unattractive. Why is it unattractive? Because you can see these lines that are really not necessary. You don't need this type of a very bold, strong lines as your frame. So that is what makes it unattractive. Now let's look at the other figure. That is figure number 2. It is named as poor. And why is it poor? Why do you think it is poor? You can send me chat messages. Why do you think it is poor? This is number 2. And why do you think it is poor? Poor in the sense the word poor indicates there's some greater room for improvement. So it is poor. So we got a message. Can't compare. Any other wrong scaling? Okay. Any other? Can't compare, wrong scaling. Any other matter? Right. So yes, it cannot be compared because this one and this one has no common scale, right? Even though it starts with 0, maybe we don't know, it's the same level, but from there onwards you can see the unit steps here, it goes like that, but the unit steps here, they are different. Because of that we cannot compare. Now I would not say it is wrong scaling, because when you think about wrong scaling, you need to have some sort of a right scaling as well, right? But the thing with this one is the person who developed it has developed it thinking one per time. So there is no totality in the work because you don't have ABC together, you have them isolated. So I would say it's not wrong per se. The main issue that I see here is that the visualization is developed and in its own merits, they are there. But the problem is the utility of the visualization. Like, why are you doing a visualization is forgotten because there is no point in doing a visualization if you can't get more information out of it. It's purely doing something like just because you can, you do it. Now, here, for this particular visual, you can easily say is A is 3. And for this one, B is 5 and C is 4. And within this much of a space, maybe less than that, you can actually say what you have tried to say in this entire space. So that's again data to ink ratio. What you want to say can be said within very short span, but you have used an entire space to do it. And because of that, it is not only wrong, it is also poor in representation. Okay, I hope I'm sure you get the point, and I got another message. If values for the bars are displayed on top of each bar in 3, can't it be considered correct in 3? In 3, so you are referring to the point that we will about to discuss. Okay, so yeah, now the question is, now we will look at number 3. Here, it's incorrect. It is incorrect because it is incorrect at this point. So your question is whether if we put labels on top of this or maybe indicate the value here, is it wrong? Now my question is, even if you indicate values here, since we don't have proper scaling or coordinate system to refer, we cannot compare this, right? That is the problem. It is not, if you put labels here, again, my question is, you can, if you want to put a label on top of this, on this particular bar, right? If you put a label here, then it indicates the same thing. Why don't you put A is this value, B is this value, and C is this value? It will only use a space like this. But of course, you can do it. You can put the labels maybe for grabbing the attention of the audience. You can do that. But then afterwards, how would you compare? Because you don't have those reference points. You don't have the bearings. If you have the bearings like this one and maybe the x-axis here and the y-axis here, if you had the bearings like in the first presentation, first one here, if you had the bearings like that, then even though you don't have the grid lines, if you put the labels, the actual values of your bars here, then that can be considered somewhat okay, because you have some proper scaling like this. Then of course you can compare, because now the problem is we don't know what is this particular level. If you are comparing from this point onwards, what is this fraction, or what what does this really mean? Now you can of course argue, like in a math exam or any type of an IQ type exam, you can think of the, you measure this length and then you measure the difference like that, and then you say what is the proportion. Yes, of course you can do that, but the point of data visualization is to make that cognitive load less. You are trying to improve the germane load rather than improving the extraneous load in the visual. So that's the point. I hope that is clear. So that's why it is incorrect. And in its form, in its current form, that is incorrect, because you don't have any visualization, proper data visualization here. That is the point. Now, I hope that is clear. Right. Now let's go to the next slide. So these are the three things. Of course, you can look at I'm not saying that this thing is correct, the first one. I'm not saying this one is the best one, but it has served its purpose. You have the value, you have the labels, and then the grid lines. So it has served its purpose. I'm not saying it is bad or good, but the only thing is that it's correct and it is serving its purpose. You can do a better visualization, and you can save spacing as well. Like if you think about the spacing, you can save it. That's all there. Let's go ahead. Now let's move on. So I have given some explanations and an attractive version. The plot is technically correct. It is not aesthetically pleasing. The colors are too bright and not useful. Yeah, here I forgot to mention that the colors are also not useful, because color, remember, color is a different type of scale. We have a different lecture on color theory. The color itself is a different type of a scale. So including this here, it's actually taking too much of unnecessary space there, or cognitive space. The plot is technically correct. The colors are too bright and not useful. The background grid is too prominent. A poor version, each bar is shown with its own y-axis scale. The misalignment of the scales makes the figure misleading. One can easily get the impression that the three values are closer together than they actually are. And then the inaccurate version, without an explicit y-axis scale, the numbers represented by the bars cannot be ascertained. Presumably, the bars appear to be of length this one, even though the values displayed are meant to be 3, 5, and 4. That also is there. I forgot to mention in that slide, because since there are no values here, we certainly don't know what actually meant by each of these things, right? So someone can, even if the value of A is greater than B, you can put a little bar like that, and B can be exaggerated like this, but we never know how to compare. Like A can be 5 kilograms and B can be 500 grams, but if you represent 500 like that and 5 like this, then obviously it's wrong, because A should be 5,000 grams, right? So there's a difference that is there. Now let's go ahead for the next one. Now the entire exercise of visualizing data is associated with mapping data into aesthetics. So what do you mean by data and what do you mean by aesthetics? So there are commonly used aesthetics in data visualization. I have given 6 types of aesthetics. The first one is the position. Now, if you remember our previous lecture, I think we had a little discussion about this, which one is easier to grasp, right? For us, position is the easiest as humans. And then we have shape, size, color, line width, and line type. So position, you have two control lines like X and Y, baselines. And you can, on the 2D space, you can give wherever you are based on these X and Y baselines or coordinate references. You can say X comma Y to indicate the position. And the shape, of course, is easier to understand as well. From Stone Ages, we are used to understanding the shape, the round shape, squares, and diamond shapes, etc. And of course, the size. Now, remember, we are looking at them from individual point of view, like isolated, independent point of view. You can change the shape and at the same time change the size as well. Now, that is a combination of shape and size. You have multiple ways to show this, all right? So, but of course, again, when you are thinking about shape and size together, think about like if you increase the size of this one and increase the size of this one to indicate something, some particular value, then there would be an issue how to compare the circle and the diamond shape, because when you have a shape and its size changing, it's very difficult for us to understand the difference, like the rate of change or what is actually changing there. That is there. You can, of course, use them interchangeably together as well, but in a more cleaner version, if you say, a size can be taken with a single type of shape. So you can see as the size increases, something is changing. Size increases, something is changing. And then color, I told you color itself is an aesthetic to map the scale. So what we do is we have a number, a value, and then we use these aesthetics to indicate the variation of those things to map them. There should be some link between that, right? If the position is changing from here to here, we can easily say this is the first place and this is the second place. Similarly, if you think about the shape, this can be taken as maybe someone like people who are using iPhones, and this can be taken for people who are using Androids, and then this can be for maybe using none of those type of devices. So that indicates some sort of a difference classification in the data. And size can be like the population or the average value of something. So that is size. And the color can be, it can be a continuous value, it can be discrete value, and also it can be a qualitative variable as well, like gender, can be ethnicity, can be also the rate of change. Like you can say starting with like pink color indicates lower, it is risky, but lower end of risk. And red color indicates higher end of risk. So the color indicates some variation in the risk level. Then, of course, line width can be also taken as an aesthetic, because the width changes can indicate the differences between maybe classes, right? You can have a thicker line to indicate one type of class, and smaller or uh, low, small width line to indicate a different class. And of course, line width itself can be taken as a measure of something, like to indicate area-wise measure. And then line type, of course, it's also a classification type aesthetic. So position, shape, size, color, line width, and line type, these are aesthetics. And some of these aesthetics can represent both continuous and discrete data. As I mentioned, like color is a very powerful aesthetic. It can be used to show continuous and discrete data. And position, of course, size, line width, and color. While others can usually only represent discrete data like shape and line type. I'm sure we are using this even though we don't necessarily think about it, like shape and line type. Whatever you change with these two, whatever you try to do with them, it will always be about some sort of a classification, some sort of a class. So that's class or a discrete value, right? That is the thing about aesthetics. If you have any questions, please send them. I'm continuously monitoring the chat. Now let's move on. Now, types of data, we have discussed this in the previous lecture, but we can also refer to that. You have quantitative data and qualitative data, discrete data, continuous data, right? So all sort of data is there. You can refer to it, and of course, I'm sure at this day and age, we have to be very careful of what is actually the data type that we are referring to, because we have a lot of data now, and we have to have a good idea about which one is categorical and which one is quantitative when it comes to our data visualizations. Okay. For example, sometimes the number of people, even though it is a discrete quantitative variable, we can convert it to a categorical variable as well, depending on the context. So it's somewhat beyond the scope of this lecture here, but there are ways to do that. So we have to understand what is actually shown in that data. Otherwise, it can be misleading. So types of data. And this is the important thing about the data visualization. The scales map data to aesthetics. So that's something that you have to keep on memorizing or trying to put it into your system, that a scale, if you have a scale, then the scale maps values onto aesthetics. How does it happen? As the first word says, to map data values onto aesthetics, we need to specify which data values correspond to specific aesthetics values, such as x-axis positions or shapes or colors. Now you can see one-to-one scale mapping, this little blue color line here. You can see this one. This one. So if you look at the position as your first aesthetic, right? Position is the aesthetic. And these are the values, 1, 2, 3, 4. These are the values. And we are trying to map them, right? We are trying to map them to the position, to the data. So 1, 2, 3, 4 are the values. Position is our aesthetic. We inherently do that. That's why I'm iterating this so much. So when you draw a line, I think your grade 4 teacher, I don't know when you are starting to do this on the number line, maybe grade 4, I think. Grade 4, grade 5, we are doing the number line if I'm not sure. Some of us are homeschooled also, so we don't know when we started learning mathematics. So we have a number line, and on the number line you have 1, 2, 3, 4. So the numbers are there, and we inherently from our early age we know that if the number line is like that, if 1, 2, 3, 4 are like that, and then the position, we just keep on putting the points to indicate the position. So that's actually mapping the data to aesthetics. Position is our aesthetic, data is what we have, and we are mapping the data to the aesthetics using the scales. Because if you don't have a proper scale of the unit length between these two values, right, then you are wrong. Remember? So you have to make sure that the length between these things are scaled. So that's the point. Scaling allows us to map it. So that's about in terms of position. Now let's move on to our shape. Now think about the shape as well. Shapes are different. This one and this one and this one and this one. These are different shapes, of course, but they are indicative of these values. So one is for the circle here, two square, and so and so. So it's also a mapping. It's also a mapping. It's a scale because the scale in this case is the shape. Aesthetic is the shape, but scale is the shape, like if it is circle, square, you can have multiple types of shapes. And if you are into to think about different shapes in terms of the number of edges it has. So you have 5, 6, 7. You can go like that as well. So it's one-to-one mapping, one-to-one scale mapping. Now look at the color. Now I have used a square to indicate the color, but of course it's for our ease of understanding because I don't have any other way to put the color here. So think about it. You take one as this color, this first color, and then two as the other color, and three and four, and so and so. So you can have different gradients of the color to indicate that particular number, the value. So that is what we call one-to-one scale mapping. It can be, it has to be unique. That is the thing. To make it, mapping is created by our one-to-one scales. That's very important. One-to-one scale, such that for each specific data value, there is exactly one aesthetic value and vice versa. So if I was talking about this in the class, we would be thinking about like love affairs, right? It has to be one-to-one. Maybe we can agree to disagree, but it is one-to-one in terms of one person has one partner, if that is the case. But I mean, that there are correct things and wrong things, but certainly I'm not talking about the social life. I'm talking about the data visualization. So here it has to be one-to-one. So you have one scale representing one particular aesthetic so that the data can be linked. Now in the table 2, we have some data points like for month, day, and location. And then the station ID, this is from temperature stations like weather stations. And you have the ID and the temperature in Fahrenheit. This is from a US data set, month, day, location, station, and the temperature. This is a table. Now let's look at how we can visualize this following our idea. Okay, let me clean this up. So these two visualizations you see on the slide, this one and this one, right? These are two types of visualizations. Now let's focus on the first one, daily temperature normals. Daily temperature normals. As we map temperature onto y-axis, day of the year into x-axis, and location onto color, a standard line plot is created showing temperature normals at 4 locations. However, for a more detailed visualization of the temperature variation, we need to employ a different visualization. Now, I will skip talking about the text here, but look at the visualization. In the first visualization, what do you see? I'm referring to the first visualization. Can you write what you see and send me in the chat? What you see in terms of the visualization, what you feel about the visualization, what if you were to write about the visualization, what is the thing that is being visualized and how it is done? Can you write it? I'll give you 5 minutes or 2 minutes to save time. Look at the visualization. I'm referring to the first one, daily temperature normals. What is being visualized and how it is being done. Write in maybe 2, 3 sentences and send it to me in the chat. I'm referring to the visualization itself, not anything related to the data or anything. I mean, what is the trend or anything? I'm not referring to that. I'm referring to the visualization. Yeah, Dilashni, I totally get what you say. That's right. Great for noticing it. I'm referring to not to the trend, but I'm referring to the visualization. How it is been, what type of things are visualized and how it is done. For example, if I were to write a sentence like to indicate the locations, color is used, something like that. I'm referring to the visualization itself, not the trends or anything as such. We'll talk about it in a few minutes about the trends. Okay. All right. I got another message. It is useful comparing temperature patterns, but it's harder to read detailed monthly difference. Clearly, it visualizes temperature levels of few cities in USA over the months. Now, all of your answers are great. You have identified what is being visualized, and so we are trained to do that, right? That's true. But I'm asking about the scales and the mapping that has been done here. Now, if you watch a movie, we when we watch a movie, we forget it's a movie and we start to appraise the story behind it. I'm not asking about the story. I'm asking about the way the movie was developed. Like, for example, if you think about the starting of maybe, for example, Lord of the Rings movie, the first one, you can see the setup, right? You have the hobbits, a very nice calm environment, and then the colors, the greenery, and then how the journey goes on. I'm asking about how the movie was created, not the story. That's what I'm asking. Okay, so basically, if you look at the daily temperature normals, you can see Death Valley, Houston, San Diego, and Chicago. You have 4 locations. In this particular visualization, color codes or the colors as a scale has been, the aesthetic is the color, and the scaling is the name of the place or the station location. So the color indicates the location, that the location is mapped by the color. All right, and the position of the temperature and the month, you can see there's a position, right? X-axis is a month scale, and it's indicating the month, and the temperature is on the y-axis. So basically, the x-axis has the time on it, and the temperature is on the y-axis. So the position on this one is used to indicate the rise and fall, or how it is moving along the time, right? So you can see on the y-axis, the temperature is in 20-degree intervals. So the mapping is happening for different temperatures. You have that particular, the scaling, and you use that to indicate where you can find it in time. Now, that is how the movie is developed, right? So you can see now the story is there. Of course, we are trained to understand the story, but data visualization is also about developing the movie. The story is there. It is what you want to say to the audience, but you are the person who is directing the movie. So it's your story. Now, if you move to the right-hand side, monthly normal mean temperatures, there is something missing in the first one that we can do better in the second one. That's why. There is no right or wrong answer. If you look at the same Game of Thrones, or sorry, Lord of the Rings movie, someone else can develop the movie in a different way, right? It can be a different director, and that director wants to show something else, right? It depends on what you want to show. Now, in the case of the second visual, monthly normal mean temperatures, you can see now the color indicates temperature, and position has been given to the Chicago, the location and the time, because we are using the colors now instead of the continuity of the time, right? Showing now, if you think about January, April, if you are using the x-axis, but in this case, month itself is used instead of the time. So if you are going with that, then we are using the same positioning, but now we have swapped the location and the temperature to the color scale. This is a different movie, same story, but we are trying to give a different emphasis or think about different characters in the movie. So if you think about now, like if you think about the Lord of the Rings movie, I'm sure you have, at least majority of you have watched Lord of the Rings movies. So if you think about the movie, you can write it from how Bilbo Baggins is taking the ring, and then the ring is taken, and you have Saruman and everybody, trying to, the good and evil, you try to get rid of it at the end. But what if you look at it from the villain's end? Like there is a villain who was villain is putting his heart and soul to achieve this victory over the earth, whatever that is there, and then you have you've been killed, right? And you believe on a certain ideology that you think that you are the savior of this, and some human comes and cut your ring, and then the challenges as a villain, right? You can project the story in that way as well. So that's it, like the same story but two different perspectives. But if you look at it now that you look at it from that angle as well, you can see it has a different story to tell. Now, that's the most important thing. Scales map data to aesthetics, yes. But at the same time, what we need to understand is we are the ones who are directing this. So, as long as you have that idea that what you really want to visualize, you can swap between it. And uh, I think there are a lot of drawings happening on the screen. Please don't draw on it, it's a bit disturbing. If you are in the Zoom and maybe you are putting this into the pocket, as you move, the phone gets touched, and then you see these lines. Anyway, so let's move on. Again, this one, the visualization is about fuel efficiency versus displacement, but you can see all sort of the the scales and the aesthetics have been used here. You can see the position. So can you tell me what are the things that you can see in the chat? Here, what are the scales? Sorry, what are the aesthetics being used to map the values to the scales? What are the things that are being used here? Yes, size and shape, and how it is been linked to the data. What type of indicator is there? What is the scale of shape or size or color, and what is it representing? So you have shape. The shape indicates cylinders. right? Size, shape, and saturation, right? So you have the cylinders, 4 cylinders indicated by the diamond shape, 6 by the triangle, 8 by the circle. So those are shapes, and the shapes have been linked with or mapped to those values, right? Data has been mapped to those aesthetics. That's what I want you to understand. Excellent. Yeah, cylinder type shape, cylinder weight, size. That's what I wanted. So you can see the data has been linked to the visuals, the aesthetics, and you can see this the size, the weight of the car is being linked with the size of the circle. So you have a circle, but the circle size indicates the weight, right? So basically, if you now remember previously, I told you that you can combine the size and the shape, right? Here you can only see the circle, but that also is about other type of shapes as well. Now, if you think about only circle size is given, it is not really the case. If you have, for example, a triangle and the triangle shape is large, then that indicates the weight of the vehicle. So that is what I said. Now it's very difficult. Now there is also, now, any visualization has a problem. That is, we have to understand. You can see the circles are easy to understand, but if you think about triangles, we don't really necessarily know which one is smaller and which one is larger. That being said, of course, we don't know the level of the size. We cannot distinguish easily. For me, I'm not sure about others. For me, it's very difficult to understand if you take a triangle, which is indicating about the number of cylinders in the vehicle, but we don't know uh, what is the weight of that vehicle. If it is 2 and 4, take a look at the 2, 3, 4 there. If you think about the triangles, it's difficult for me to distinguish between the sizes. That's what I have as a problem. So that's what I said. You can combine different types of aesthetics, but it's very difficult to actually understand what is actually happening there. For me, it's easy to understand if it is circles, but if there are other shapes and you're trying to change the size of it, it's difficult. And power is indicated by the color, horsepower. So if the color is towards the lighter side, you have higher horsepower, right? So this is a visualization and it has a lot of details. If you just read this one, you can write a lot of things about this particular um, visualization, the displacement, the fuel efficiency. Now, can you tell me, now I'm asking about the story, not the way the movie was created. I'm asking, what can you tell from this? Any one message you can take from this, a simple message. Sorry. Can you send me a message? What is the message? What is that one story you get out of this visual? Any message you get? I'm asking about the story. Like you can easily say a hobbit getting the ring, and then hobbit received a ring from his uncle, who got it from Gollum, and you take the ring and then you destroy, so you destroy the evil, something like that. Very simple story, one line. What do you get from this particular chart, particular figure? What is the general trend? Okay, great. Fuel efficiency is inversely proportional to displacement. Fuel efficiency is inversely proportional to the displacement. Correct. Efficiency is high in type 4 cylinders. Okay, very good. We have looked at it very carefully. Fuel efficiency is high in type 4 cylinders. As displacement increases, fuel efficiency decrease. Yeah, because when the engine is large, the fuel efficiency decreases because you need a lot of fuel to fire the engine. So that's it. Very good. So you have this type of information. See, now three of you have three different opinions about the same figure, and that is what visualization is about. So if you try to write it in a paragraph, nobody's going to read it. You can start writing it right. We analyzed fuel efficiency versus displacement for this much of cars, and according to our analysis, this is what you get. If you write it on a figure or on a paragraph, then probably nobody's going to read it and nobody is going to understand it in this way. But all of us can look at this and then actually agree on the points that you raise, and at the same time every one of us can actually look at it and then see what you can come up with, maybe compare it, maybe try to find out, like for me, this 300 displacement and 15 fuel efficiency mpg is more pronounced in terms of power. So that seems to be an ideal position to be. If I am to buy a car, maybe if I am not into fuel efficiency, not in this day and age, of course, but maybe if I'm a fan of high power engines. So if that's the case, maybe I'll be moving towards maybe four cylinders, an 8-cylinder engine with maybe fairly decent fuel efficiency in terms of its power. So you can think of that as well. Now let's go forward. Director of Visualizations directory, we have already talked about this in the previous lecture. This is linked to that. So you have common visualizations for mounts and distributions. Like univariate means you have single type of variable. Bivariate is, or multivariate means you have multiple types of variables with their distributions, and proportions and XY relationships. Geospatial data, I'll talk about it in very simple terms, maybe when we come to Power BI. And you have uncertainty. Uncertainty you have learned in statistics. So these are the things that we try to visualize with different types of visualizations. Now, these are the things that you have in your default arsenal. You have all these visuals, but the way that you organize them is totally up to you, because someone can use pie chart and someone can use a bar chart. Different impressions, different organizations. And if you are using vertical bar charts and horizontal bar charts, it depends. Also, that have a different impression, right? Maybe you are trying to say something, and there the horizontal bar chart is more suitable than the vertical bar chart. So that depends on the position that you are in. It's like a language, actually. So when you are trying to write a novel, if you want to like more of a modern novel, if you are looking at, if you are trying to write a novel today, and you have a lot of Gen Zs and Gen Alpha in as characters, then you have to learn their slangs, right? How they are talking, how they are expressing themselves. So themselves, then you have to read their way and put that into the story. So it depends on what are the characters in your story. So likewise, when you are developing a visualization, you have these things like the language, transitions, the words, the paragraphing, and all these things. Like in a typical novel, typical writing, the visualizations are there. But how you organize it is the way that you write it, the way that you present it. So that's the difference. So if you think in terms of that will be a very good analogy, in my opinion. It will give you a lot of insights to how you are going to visualize things. Now, that is about the art and science of visualization. It has a lot of art, as in my opinion, it has a lot of art. It has a lot of science as well. If you understand the science, then you can develop the art. If you develop the art, inherently the science will be there. Right, that is the second one. So we have grammar of graphics. That is also going to be a simple lecture. We'll try to finish this within the time limit. Not a lot to digest, but it has some merits. Now, We will be moving towards programming as well, like visualizations using R and Python. So this is a good transition point to understand how the graphics are developed. So you have grammar of graphics. What is grammar of graphics? Now, I've been talking about these novels and the language, the visualizations, and how we can combine these things to visualize. So grammar in the language, grammar indicates the way that you write, right? That if you say if it is a single person, you have like there's a way to write in English. There is a way to say about past things. So grammar of graphics is the way that you organize graphics. Now let's look at these organizations. Now, so far we talked about the movie making. Now this is like scene making, like how you uh, take that shot, right? If you think about, again, I'm referring to a lot of Lord of Rings, because I got to watch it yesterday. So if you think about that, think about the shots that you make, right? You can start with a closer shot and then you can go move further so that you get a big view of it, or you can start from far away and then come closer, right? You have different ways to do that. So that's grammar of graphics. Now let's look at, there are five things that we will discuss. What is layered grammar of graphics, the layering, and then what are the layers? The layers are data mapping, statistical transformation, geometric objects, and position adjustments. Then you have scale. We talked about the scale in very few minutes ago. So you have coordinate system. Coordinate system is the most important thing when it comes to developing visualizations, data visualizations. Coordinate system has to be there, and it is like that the setting up of the movie, right? If you are talking about medieval England, you have to have medieval costumes, the houses, the castles, and all these things. If you are talking about like post-apocalyptic era in a movie, then you should have like deserted, the bombarded places with all the fragments. So that's the background, the setting up. That is very important because without that, there is no context to the movie. Right? Coordinate system is like that. Without that, you don't have a context to your visualization. So coordinate system is very important. And let's go on. What is faceting? Of course, that's organization of the visual. So let's see. A grammar is a structure of a language, including syntax, morphology, and semantics. It is also the fundamental principle of art or science. In visualizations, the grammar of graphics is used to describe and create statistical graphics like ggplot. We'll talk about R. There is an R component here, but I will do it later. So just focus on the theory part of visualization. So you have a layer. The layer itself has data and the mapping. This is what inherently happens when you try to visualize. Now, if you think about the number line is there, and it doesn't have any meaning unless you combine data with it. So data and mapping has to be there. It's default. Then you have statistical transformation, how you put it, maybe log scale, maybe different types of scaling. Then the geometric object, the shape, size, all these things matter in the geometric object. Then the precision adjustment, how you put it. Scale, coordinate systems, and the facets. So these codes are from R, facet code, position, geom, stat. These are from R, and the codes are there. And then Wickham 2010 is the paper. So Hadley Wickham is one of the pioneers in this area. He developed this grammar of graphics, and his paper is cited here, Wickham 2010. I'll try to, if you are interested in, I can put that paper in the Moodle as well. So you can go through it. So Wickham 2010 is the paper. In the layer, you have five basics, the 5 parts that construct a layer. Like in grammar, you have, I'm not a good English student, I don't remember how it is done, but you have like I am, you are, like she is, something like that. So there's a structure of it. So the structuring is what this layer is. So layers are interconnected and share common features, like using the same data in multiple layers, like a scatter plot overlaid with smooth regression line. So basically, this the way that you organize it: data mapping, statistical transformation, and geometric objects. So you have one line and several dots to indicate dots, the points, like that. A plot with two layers, a scatter plot, and a smooth line, because you have two plots basically. So you have the scatter plot as dot, 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 and the line that indicates. And moving on to the next one, forget about the R codes, because grammar of graphics is from R. I'm using it to indicate how we are developing it. So data defines the source of the information to be visualized, but it's independent from the other elements. So a layered graphic can be built with utilizes different data sources. So you have multiple data sources you can combine. And mapping, we talked about it. Mapping defines how the variables are applied to the plot. So if you are graphing information from penguins, we'll do this when we are starting R. So you might map penguin slipper length to the position and the body mass to the position. So you have data and you are linking that, you are mapping it to aesthetics. And then the statistical transformations and the geometric objects, right? You have dimension, 0, point, and text. Then dimension 1 for the path and line, dimension 2 for the polygon interval. These are the three things that we'll be using when you are doing 2D maps. Each geom can only display certain aesthetics or visual attributes of the geometry. And so this is the way that we get the visualizations. And the position adjustments are when you are having like stacked bar chart or clustered bar chart. You can see the difference. These two, the output figure, here they are stacked together on top of each other, and here they are clustered. So there's a particular importance, right? If you want to talk about like comparisons, like in terms of the proportions, you may be stacking them together. Of course, you can have a cluster like this as well. So there's a technical way to do it in R. So you have the keywords, uh, the arguments, position adjustments, how you show it, and then the scale, the way you are doing it. So that's it. The coordinate system. Coordinate system is there. So read this one. It's not that difficult, and it's like looking at the visualization from a language point of view, from a grammar point of view. Have you organized things? If you think about it, actually, it has a lot of merits, because if you want to write a novel, if you want to understand the context of that novel, the story that you want to say, then you know the language that you are going to use. Are you going to invent a new language to talk about? Maybe there are tribes in the story, so the tribes are talking about in a different language. So that's like statistical transformation. If you are looking at like the context, as I said, medieval England, post-apocalyptic or neo feudalism, and all this, the context, you have a different way to write it. You don't say like, if you say computer in even in 1870, for example, computer, it has no meaning in that era. So you can't write a novel and somebody is referring to check your WhatsApp when you're writing a novel about 1870, some love story, and saying that you have to check your WhatsApp. There's no meaning. The novel has no context. So that's why great writers actually have a lot of things in their novels, very deep, very systematic details. So the visualization is like that. Okay, now let's move on to the most important thing um, of your previous work, that is related to Power BI. So I'm going to stop this recording here because the lecture part is done. You have already got the Power BI recording. Because of that, I'm going to stop this recording and I'll upload it because this is part of the lecture. And I'm referring to minimize your load and also to make it easy for everybody to follow.